Now let us look at the classification of ligands, or you can call it as types of ligands also. Ligands can be classified based on denticity, ability to use one ligand at a time, and on charges. Let's go for first one. Classification of ligands based on denticity. Well, denticity stands for number of donor atoms present in the ligand. If only one donor atom is present, such as in Cl-1, this itself is one donor atom. This H2O has got O as one donor atom. This NH3 has N as one donor atom. Such ligands are called as monodentate ligand. This mono stands for single. The ligand which has got only one donor atom is called as monodentate. Similarly, if the ligand has two donor atoms, for example, in 1,2-ethane diamine, there are two donor atoms. Therefore, it's called as bidentate or didentate ligand. Similarly, oxalate has two donor atoms. Hydrazine has two donor atoms. Such ligands which have got two donor atoms, they are called as bidentate ligands. There is another thing. If a ligand has more than two donor atoms, it can be called as either tridentate or polydentate ligand. Here in this molecule, there are three donor atoms, four donor atoms. Well, there is a special case of polydentate ligand which is called as flexidentate ligand, which is known as ethylene diamine tetra acetate ion. This is also called as EDTA raised to 4 minus. It is used in the determination of hardness of water. Ethylene diamine tetra acetate ion. It is basically a hexadentate ligand it can donate either 2 or 3 or 4 or 5 or all, depending upon how many donor atoms are required by the metal. Therefore, it has got flexibility of donating the donor atoms. Therefore, it's also called as flexidentate ligand. That means for a ligand to be flexible, it should be polydentate ligand. More precisely, it should be a hexa, more than 3 donor atoms you should have. Okay, there is a second type of classification. This classification is based on the ability of the ligand to use one donor atom at a time. It simply means that a ligand should have more than one donor atom and can utilize only one at a time. For example, in NO2 group, there are two donor atoms. One is nitrogen, another one is oxygen. It can utilize only one at a time. If it uses nitrogen atom for binding with the metal, then it's called as nitrito-N. This N indicates that NO2 has utilized N as donor atom for binding with metal. It can utilize, instead of N, O as a donor atom to bind with metal. Then it's called as nitrito-O. This letter indicates which atom is utilized by NO2 group for forming bond with central metal atom or ion. Similarly, we have thiocyanato as ambidentate ligand. For example, if SCN utilizes S as a donor atom to form bond with metal, then it's called as thiocyanato S. Or if it utilizes N donor atom for bonding with metal, then it's called as, instead of isothiocyanate, we can even call it as thiocyanato N. Therefore, a bidentate ligand necessarily should have two donor atoms, but it should use only one at a time. So a bidentate ligand or the ligand which has got two donor atoms but can utilize only one donor atom at a time, such ligands are called as ambidentate ligand. This word has come from this ambiguity. Well, there is another type of classification of ligands based on the charges. The ligands can have negative charge, such ligands are called as anionic, or positive charge, such ligands are called as cationic, or they do not have any charges, such ligands are called as neutral ligands. The names of negatively charged ligands end with ate, A-T-O. For example, it's called as sulfato. This is called as carbonato. This is called as acetato. So just by looking at the name of the ligand, we can decide what is the charge on it. This is called as nitrosonium. This is called as nitronium. And this is called as hydrazinium. Just look at this name. If the name of the ligand ends with IUM, then it is a positively charged ligand. If the name of the ligand ends with ATO, then it's called as negatively charged ligand. Whereas there is no such special ending in the name for neutral ligands. It is called as ammonia. It is called as aqua instead of water. This is called as carbon monoxide or carbonate. This is called as pyridine.